All right, so we're going to go ahead and get started on 5-3, and we're doing the same thing that we've been doing in sections 1 and 2, but we're adding some more identities that we can use. And again, these formulas are on your identity sheet, and so you can reference them there. And let's go ahead and get started in just using them. We'll get into verifying again, but let's just go ahead and practice using them. So we're told that sine x is equal to 4/5, and that our angle is in quadrant 2, and we want to find the exact values of the following. Now again, anytime we see the word exact value, that means no calculator. So we know that sine of x is in quadrant 2, so our angle's in quadrant 2, and that sine is going to be opposite over hypotenuse. So we have 4/5, 4, 5, and then I can use Pythagorean theorem to find out that this is going to be 3, and it's negative because this is the negative x-axis. So I want to find sine of 2x. Now, using my identity sheet, my double angle for sine of 2 theta is 2 sine theta cosine theta, and then you'll also want to reference these in a minute here. So this is 2 sine x cosine x. So sine x we know is 4/5. Cosine x is going to be adjacent over hypotenuse, so -3/5. And 2 times 4 times -3 is going to give us -24, and 5 times 5 is 25. And that's our answer. So sine 2x is equal to -24/25. Let's look at the next one, cosine of 2x. And we can use really any formula we want because we already know sine x. Let's go ahead and use cosine 2x is equal to 1 minus 2 sine squared x. So then we have 1 minus 2 times sine x, which is 4/5 squared. And that's going to give us 16/25. 16 times 2 is 32. And we have 1, which we can rewrite as 25/25. And 25 minus 32 is -7/25. Okay. And the next one, we have tangent. So tangent of 2x, we have a formula for. This is going to be 2 tangent x over 1 minus tangent squared x. And so we can go ahead and find what this is. We need to find out what tangent of x is. So looking back at our diagram, we have opposite over hypotenuse. So tangent of x is equal to -4/3. And now we can just evaluate. We can plug it in. So 2 times -4/3 over 1 minus -4/3 squared. And that gives us -8/3 over, and we have, this is going to be 16/9, and then we can turn this into 9/9. So -8/3 times 9 minus 16 is going to be -7, so this will be -7/9, multiplying by the reciprocal. That reduces, those cancel, and we have 8 times 3/7, which is 24/7. Okay. Now we're given something else. We're going to use the double angle formulas in a different way. It says find the exact value of cosine squared of 15 degrees minus sine squared of 15 degrees. And again, exact value means no calculator. So 15 degrees is not something we know on the unit circle. So that kind of leads me to believe we're going to need an identity. Now, cosine of 2 theta is sine squared theta, cosine squared theta minus sine squared theta. So, in this case, theta equals 15 degrees. So, this is equal to cosine of 2 theta, which would give us cosine of 30 degrees. which we know is root 3 over 2. And that's one of the ways that these identities make work a lot easier for us. Going ahead and flipping the page, we're going to get into verifying. So now we have sine of 3x equals 3 times sine x minus 4 sine cubed x. So the first thing I'm going to do is rewrite this left side here as sine of x plus 2x. And from there I can use the sine addition formula. So we're using sum and difference here, so we're going to use the addition formula here. So that'll be sine of x cosine of 2x plus sine of 2x cosine of x. And notice here that on the right side, we don't have any cosines. So I want to figure out ways to simplify this so that these are no longer here. So I know that I have a double angle formula for cosine. I can replace that with 1 minus 2 sine squared x. And then I can also, let's see, I can replace this sine double angle because there's no double angles here. I can have 2 sine x cosine x and then bring down this other cosine x. So I replaced this with this, and I replaced this with this. Okay. And now we can go ahead and distribute, and I can combine some terms here. So sine x minus 2 sine cubed x plus 2 sine x and cosine squared x. So now I want to replace this piece right here, and I can replace that with 1 minus sine squared. And 1 minus sine squared x. So sine x minus 2 sine cubed x plus 2 sine x minus 2 sine cubed x. And now we can combine like terms. I'll carry my equal sign through here. So sine x and 2 more sine x is going to give me 3 sine x, and negative 2 and negative 2 is negative 4 sine cubed x, and that's exactly what we wanted. So we're done. Now we can look at the next one, and this is one that usually gives students a little bit of trouble at first. So we're going to go through this one hopefully nice and slow. I am going to be telling you ahead of time what identities we're going to use. So we have sine to the 4th power x. And we want to have it with no powers of trig functions greater than 1. So we want this for no powers higher than 1. So kind of implies we're going to use the power reducing formulas. So we're going to use this formula, and we're actually also going to need this formula. So I'm going to write them down here for us. So sine squared theta equals 1 minus cosine 2 theta. And cosine 2 theta equals, oops, this is over 2, 1 plus cosine 2 theta over 2. Okay, so we're going to just kind of use these, so I'll put them right there. Now we have sine to the 4th power x, and I'm going to actually rewrite that as sine squared x times sine squared x. And then I can replace those with 1 minus cosine 2x over 2 and 1 minus cosine 2x over 2. Okay. And now we can go ahead and FOIL, and we're going to have 1 minus 2 cosine 2x plus cosine squared 2x all over 4. Now we're almost there. This is the one piece that's giving us some problems here. So what we're going to need to do is use the power reducing formula for cosine, and that's why we wrote that there. So I'm going to pull the rest of this out so that we have the 1/4 minus, and 2 over 4 will reduce to 1/2, so cosine 2x over 2. And plus cosine squared 2x over 4. All right, so what we want to do here is use the power reducing formula on just this piece. So I'm going to carry the rest of this through. And I'm going to pull this 1/4, this 4, I'm going to pull it out front here. And we're just working with this now. So going from just theta to 2 theta, this 2x gets multiplied by 2. So 1 plus cosine 2 times 2 is going to be 4x over 2. And so that brings us to 1 over 4 minus cosine of 2x over 2 plus, now I have this 1 over 2, and 1/4 is going to give me 1/8 plus cosine 4x over 2. Now these are like terms, so I can combine them. If I have a common denominator, times 2 over 2, that's 2/8, and 1/8 is 3 over 8, minus cosine 2x over 2, plus cosine 4x over 2. And that's it. You will see another problem very similar to this, either on a quiz or a test or your homework, so make sure that you really understand this process that we're going through. Okay. And looking at these next problems, they're going to take us a little bit of time, so I'm going to go ahead and split this video up into 2 parts. So we'll start part 2 again.